All right, so lesson 12, video number 2. So now, how can we use conditional probability to test for independence, right? So conditional probability and independence. So if we let two events, so A and B are our events, who cares? So if the events A and B are independent, then the conditional probability of B given A also equals the probability of B. And the conditional probability of A given B also equals the probability of A. What this is essentially saying is that if the two events are independent, then the probability of B happening given A is the same as just the probability of B. What this is saying is it doesn't matter that the other happened. So in this circle, this doesn't matter. It doesn't matter that A happened. It doesn't matter that A happened. The probability of B is going to be the same as the probability of B. Okay. Similarly here in the second one, right? The probability of A given B equals the probability of A. In this one, this is saying that it doesn't matter that B happened. The probability remains the same. Okay? And vice versa. If you switch this idea around, so now if the situation is true, then you can tell that the events are independent. We're actually going to use this, right? So they're going to say, can you please test to see if the events are independent? So you're going to pick the two events, you're going to find the probability of one of them, and you're going to find the probability of that same event given the other one happened. And if they come out to be the same, then you know they're independent because it doesn't matter if the other one happened. The probability of the event that you're looking at remain the same. All right, so let's try to utilize this idea in a problem here. All right. So example 2, use the test for independence. The table below shows the vehicles in a parking garage one afternoon. A vehicle in the garage will be selected at random. Let B represent the vehicle as black, and let V represent the vehicle as a van. So B is black, V is van. Are the events B and V independent or dependent? Okay, so I'm actually going to introduce two methods to you. The first method we're going to use is the method we just learned, the conditional probability method. So conditional probability. Conditional probability. So we need to test to see if the probability of B given A is equal to the probability of B. If that is the case, right, then we're good. Now it doesn't matter what is B and what is A. It doesn't, okay? So let's find the probability that we are, again, it doesn't matter. Let's just go in order. Find the probability of V being a van given that we're black. Again. And compare that to the probability of being a van. Right? And see, are these two equal? So again, it doesn't matter what order, but if this were B, where the V is, then this better be V. So whatever comes first here, that's the probability you find over there. All right. So let's do these two independently. So find the probability of V given B. So that's going to be the probability of V and B over the probability of B. So where is the V and B? So where's the vans and the black? So that would be 3. So there are 3 black vans. And then the bottom is the probability of B. And what's the total number of black? 13. So again, we're looking at the black row and saying in the black row of 13, how many are vans? 3 out of 13. All right, great. And now I need to find the probability of being a van. Or yeah, probability of being a van. So now I just look at the van total, 3. Out of the total, 22. And the question is 3 out of 13 equal to 3 out of 22? And the answer is no. The top numbers are the same. So these are not equal. So because they're not equal, B happening, the fact that the car is black it affected the probability of being a van. So these two events are not independent. Independent. Sorry if I could spell. I get my chicken scratch. So that you have to listen to me. Independent. So because those probabilities were not the same, they are not independent, which means they are dependent. They have some sort of a relationship, right, between being a black vehicle and being a van. Right? So in just to kind of make sense of this, if you do 13 or 3 divided by 13, 3 divided by 13, you get 0.23. So this side is 0.23. If you do 3 divided by 22, you get 0.136, 0.14. So over here, this is saying that if you know that the vehicle is black, there's actually a greater chance that it's a van compared to just if it's looking at all the vehicles, right? So being black affects the fact that there might be a greater chance there's a van. All right, so that's one way to do this problem. I'm going to show you the second way on the next slide here. Method 2. So method 2, we're going to go back to lesson 12.1 and use this independence rule. If you remember, the probability of A and B should equal the probability of A times the probability of B. Okay, so let's use this two-way table. We're going to find these 3 probabilities and ask ourselves, the probability of being black and a van, does it equal the probability of being black times the probability of being a van? That's the question. So let's find the 3 probabilities. I'll start in orange. What's the probability of being a black vehicle and a van? Well, we look at where they overlap. Where are the black vans? Right here. 3 out of 22. Right? We're going to use the grand total the entire time because we're not doing conditional probability. So our total is not limited. So this is 3 out of 22. Then we do the probability of being a black vehicle. How many black vehicles are there? There's 13 out of 22. And then we do the probability of being a van. How many vans are there? There's 3 out of 22. Okay, so now we're going to put this in the formula. So does 3 out of 22 equal 13 out of 22 times 3 out of 22? Right? Well, obviously, because this is 3 out of 22 and this is 3 out of 22, having the 13 out of 22 there, they're not going to be equal, right? Just to give you some proof, right? So 3 divided by 22 is 0.14. 13 divided by 22 times 3 divided by 22, I got 0.08. Let me do that one more time just to make sure it's correct. Yep. So they're not equal, right? So again, this verifies that this formula does not work and they are not independent. Either way you do it, I don't care. I'm sure Savas is going to walk you through a certain way to do the problems. Okay, so I'm going to stop the video there again. Sorry for the third video. I just think this is heavy stuff and I want to make sure that you're understanding. So I'm going to stop this video and I have 2 more examples to do on the third video.